All right, this is another chapter 17 reassessment. The problem is a charge Q is equal to negative 50 nanocoulombs, is located 0.30 meters away from point A and 0.50 meters from point B. A, what is the potential at A? B, what is the potential at B? C, if a point charge Q is moved from A to B while Q is fixed in place, through what potential difference does it move? Does its potential increase or decrease? D, if Q is equal to negative 1.0 nanocoulombs, what is the change in electric potential energy as it moves from A to B? Does the potential energy increase or decrease? And E, how much work is done by the electric field due to charge Q as charge Q moves from A to B? First thing I did was I drew the diagram. And this is going to be our charge, negative 50 nanocoulombs. And this is point A. So from our charge to A is 0.30 meters. And from our charge to B is 0.50 meters. And over here, I just went ahead and changed the nanocoulombs to regular coulombs. So it would be negative 5.0 times 10 to the negative 8 coulombs. Okay, and then I didn't have to change the meters because it was already in meters. And the first equation we're going to use to find the potential is going to be VA, because we're just doing to point A, is equal to K times Q divided by R. So we're going to use K as our constant, and that's going to be 9.0 times 10 to the 9. And then multiply that by the negative 5.0 times 10 to the negative 8. And we're going to divide it by this R, which is the 0.30 meters. And that's going to give us negative 1,500 volts. And the same thing for part B, but we're going to use VB is equal to K times Q divided by R because we're doing to point B this time, just that point B. And it's going to be the 9.0 times 10 to the 9 times negative 5.0 times 10 to the negative 8 divided by 0.50 meters. And that's going to give us negative 900 volts. Okay, and then the change in potential is going to be delta V is equal to VB minus VA. So we're going to take the VB, which is the negative 900, minus VA, which is our negative 1,500. And that's going to give us 600 volts. And that means our potential increases here. Okay, and in the back part, we went ahead and found the electric potential energy as it moves from A to B. If the Q is equal to negative 1.0 nanocoulombs. I went ahead and changed nanocoulombs to regular coulombs, so that's going to be negative 1.0 times 10 to the negative 9th. And then the equation we use is the change in potential energy is equal to Q times the change in potential. And that's going to give us that 600 that we found down here when we subtracted the VV minus VA. That's that 600. And we're just going to bring it back here. So it's going to be that negative 1.0 times 10 to the negative 9 times 600. And that's going to give us negative 6 times 10 to the negative 6 times 10 to the 7 joules. And potential energy here is going to decrease. And to find the work done, we're going to just take this answer right here. And we're going to find the negative change in potential energy. So the negative, that it's in the equation, and then you write the negative answer that we found right here, and that's going to give us the work done, which was a positive 6 times 10 to the 6 times 10 to the 7 joules.